Okay, Science 7. Today, topic 4, the moving crust on our planet. So, we know that if we look at what our crust is composed of, we can understand the theory of plate tectonics and the idea that our crust is moving. So, first of all, looking at the parts of the Earth's crust, the crust part is this very top that's up to 60 kilometers deep, and this is where we form oil and gas, where our plants and animals live, and that crust does go down under the ocean. The next layer is the upper mantle, which is solid and made of rock. And the lower mantle is below it, and it is partly melted. So it's thick, it's flowing, and partly melted. The outer core is the iron and nickel section, and it is very hot there, 5,500 degrees Celsius, and those metals are entirely liquid. Bringing us to the inner core, the very center of the Earth, which is a solid ball, and it's under a lot of pressure because of all the layers that are above it, and so they feel like that is the reason that it's compacted and stays solid, but it is very hot there. It is more than 6,000 degrees Celsius. Now, the idea of continental drift was just sort of explained by Wegener, or he came up with this hypothesis about it, saying that all the continents on Earth once were a huge supercontinent called Pangaea. And he believed that they began to separate around 200 million years ago, and he figured it was because of the moon. Now I'm just sliding forward to just show you the photo of how the continents kind of fit in near each other, or they fit together like puzzle pieces. And so as you look at this closely, it's easy to see that it is very possible that they were once all together and have separated over time. So his ideas about this are that I'll get to the right spot here, is that not only that they look like they fit together, but also that they have discovered fossils in different continents that may have once been together. And so they feel like this is really great evidence that those used to be connected, as you can see in the fossil evidence. Also, people feel like there could be other reasons why this is a possibility, and another one is fossils. So they think that another reason there could have been fossils in those places that Wegener thought were connected is that maybe there was a land bridge at one time, or they were close enough that a tree fell over and animals could have crossed, or that the ocean was much lower and there was more land for them to cross. So there's other ideas to explain this fossil evidence. Okay, but Wegener explored a lot of different reasons why he believed in Pangaea, and he also said the mountains, looking at geology in North America and Northern Europe, had the same rocks, and also there were more fossils found in mountains of India, saying that India could have once been an island. He also found that there were areas that have evidence of where there were glaciers in places that are now tropical. So he felt like there is definitely a movement of those pieces of land. So his theory stays a theory because they say that he couldn't completely prove it, but we do call this a very valid theory that is still studied, and we do know that continental drift is something there's a lot of evidence for, and that is that the continents have moved from where they are now. They have continued to move, and there's some places where there are big continents moving together, and some places where they're moving apart. And the evidence that we have gotten from using sonar on the seafloor, this sonar is sound navigation and ranging, is what it stands for. You should know that. But anyways, it's looking at using sound waves to detect what the ocean floor looks like. And what they found there is that there are mountains at the bottom, similar to the mountains on the surface of the earth. And so those mountains had to be formed in some way from plates pushing together. They also found a mid-Atlantic ridge at the bottom, which is new crust forming because the ridges are areas where the plates are moving apart, and fresh new molten material is rising up in those spots and making new Earth's crust. So a magnetometer can also take some technology that looks at magnetic fields, and they can iron, which is very magnetic, can be examined, and they find that there's a parallel stripe and the Earth's where they're new bottom of the Earth, and they're finding that there's magnetic inversion, meaning that there is magnetic field going one way in a part of the Earth and going the other way in another part of the Earth. So they're looking at different kinds of rocks being formed in those striped areas, and that they must have formed at different times. And this is giving some evidence for the fact that molten lava has been coming up to the mid-Atlantic ridge and forming new Earth's crust, but at different times it's a different components of the metals that are in there. So what's happening is it comes up in the mid-Atlantic ridge is that the extra molten stuff is forming new Earth's crust and causing seafloor spreading, and so it'll come up and cause those plates to move apart at that spot. And they believe that at the mid-ocean ridge, it is growing, Earth's crust is growing there by 2 centimeters a year. And the plates that they have separated our globe into are constantly moving. And this is an interesting picture to examine, because where there is these two lines, we're looking at spots where the plates are diverging, which means they're moving apart from each other. And this pointy symbol is areas where they're converging and forming mountain ranges, so it kind of coincides with mountain ranges. And the ones with just a line are areas that are just sliding past each other. So you can look at the movement that is happening in all these different places, like, for example, what's happening with the plate that we're on in North America, and how it's moving compared to all the plates around us. Okay, so plate tectonics is that idea that there are some plates that are colliding or converging, some plates that are moving apart or diverging, and some that are gliding or sliding past each other. And they believe this all happens because of convection currents. And so you can see that the idea of convection from our last unit is that liquid or gas that's hotter is going to flow up, and the cooler fluid will move down. And so that idea is how the molten magma is flowing up, and the cooler materials are flowing down. So that's convection is kind of how that new mid-ocean ridge area is forming. Subduction zone is a place where high pressure is pushing a plate down under another plate, and usually that is a pretty forceful thing that can cause a earthquake in that area. So subduction zone shown in this area is showing that pressure is pushing that down, and it can cause shaking of the earth. Over here they're showing converging, or a place where plates are pushing towards each other, causing mountains to form. And over here they're showing diverging plates that are pushing past each other as magma then has a little space to flow up and form some new Earth's crust here at the mid-ocean ridge. So all those formations are in this diagram. It's a good one to review from your book. Plate tectonics is also a way that we can explain how earthquakes, volcanoes, and mountains form, which we will discuss more in upcoming topics. And lots of really great videos for you guys to check out.